remember last time we dealt with systems of linear equations, and we showed you how to basically solve two equations at the same time, find that one point of intersection. But we were kind of spoiling you because we only had two variables for each of those two equations, x and y. And life has more than two variables. In fact, two variables are only going to give you the ability to do things in 2 dimensions. We know we walk around in 3 dimensions, and business has way more variables than 3. Okay, so we want to start at least with the basics of how to find that magic point, that one point of intersection of a system of equations. These will be linear equations with more than 2 variables. And the secret to that is going to be using these animals called matrices. Now they sound hard and they look hard, but I bet in about 10 minutes you're going to say these aren't hard at all. Let's take a look.
Toto, I have a feeling we're not in Kansas anymore.
They're going to be a little bit different than what you're used to seeing, like this system of linear equations. Well, we can represent that system using this matrix. Now we're going to have special names, and I want you to know what I'm talking about when I speak of parts of this matrix. First of all, the rows. Okay, you can see that it has 2 rows. Rows go from left to right. The columns, in this case there's 3, go from top to bottom. Got the idea? Now this part of the system, the ones with the letters, if you would, is represented right here by what we call the coefficient matrix. Remember that a coefficient is the number in front of a variable. So that part of our matrix is the coefficient matrix. The other part, of course, doesn't have any variables, so it never changes, and that's the constant matrix, because it represents the constants. Together, the coefficient matrix and constant matrix will make up what we call the augmented matrix. Okay, we've kind of, augmented the equations to basically you just took the letters away, so don't think it's anything crazy. Okay? Let's try another one. Okay, see if there's any crazy things that happen. Now this is a 3-variable system. It's got an x, y, and a z. Sometimes there's a 0 in front of the x or a 0 in front of the, so we don't have them. But still, all the equations have the potential to have 3 variables. So we would represent this system with a matrix that looks like this. Consider in this case we have 3 rows and 4 columns. We still have this portion of it with the letters, all those numbers are called the coefficient matrix. Now please note, in the second equation there is no x. Well, there really is an x, it's just a 0x and it wasn't written. So we have to represent that with a 0. You have to have a number in each position. And in the third equation there was no z. There again, as you can see, there was a 0 representing that. You're going to have a number in each position. And you're going to love zeros. Remember, 0 has always been your buddy. Okay? And we still will have this portion, the portion without the variables, being the constant matrix. Okay? So I can hopefully talk about portions of the whole schmagoogie, which, as you remember, the whole schmagoogie is called,
I know that, dude.
I knew, the augmented matrix. Okay? So there's no mystery here. All we've done basically is take the letters away. Now let's try and work backwards. Okay? Let's try and take this augmented matrix and say it. Now let's try and take this augmented matrix and represent it by a system of equations so we can go back and forth. Okay, well this one would become, well, let's take it one at a time. If we go x, y, and z, it's going to be important that we be consistent with this. Okay? You're with me that that's going to be 2x minus 1y, I don't have, sometimes we write the 1, sometimes we don't, get used to it, plus 6c equals negative 11. Now what about this one? We've got that 0, and that 0 is in the x position, and we usually don't write, 0x, and we won't, so get used to that. It's just going to be 6y plus 9z equals 22. Now in the third one, the 0 is in the y position, so we're not going to have a y. And I like to leave a little space there. I'm a little anal. Okay, but you don't have to. You could have just written x plus 5z equals 13. Okay, you can see how you can go back and forth, I hope.
Well, isn't that special?
Now this matrix, let's try and go backwards with this bad boy. This is a special matrix. What would this become? Look at all those zeros. Okay, remember when they have a 0, we're not going to write the letter with it. So in the first equation, all we're going to have, and we don't write, we're going to say 1x? No, we're just going to say x. It's going to be x is 34. And you're going to know what x is. And the second equation has a 0 for the x and a 0 for the z. It only has a number for the y. And of course you love 1. So that's going to be 1y, but we don't say 1y. We say y. Son of a gun, y will be 21. And in this case, the only one that has a number other than 0 is the z. Now, this is a very special matrix. When it looks like that, and the coefficient matrix is a bunch of diagonal 1s and everything else 0, it's going to be of great use because you're going to know, as you can see, what x, y, and z are. We call that, when we have a diagonal of 1s and everything else 0s in the coefficient matrix, we call that reduced row echelon form of a matrix. You can call it whatever you want, but it's basically the answer to the system because you know what x is, you know what y is, and you know what z is. And that's usually what you wanted to know. Remember, you wanted to know x and y. Well, now we want to know x, y, and z.
Do you mind telling me what this is all about, mister?
Well, let's try and use a matrix to solve this bad boy. The first thing I'll need to do is to represent it with a correct matrix. Now you may say, Whitty, we used to solve this with substitution or addition, those methods. And you know what? That would work here, okay? But that won't work when we get to 3 and 4 variables. What I'm doing here is starting off with a very easy matrix problem, and then we'll work, and once we get the basics, then we'll work to the more difficult problems. So once again, let's start by representing it with a matrix. The augmented matrix that's going to represent this is going to look like this. Okay, you see where the 1, 3, and 8 came from the first row, and the 2, negative 1, and 4 came from the second one. Okay? Now, we're going to try and get that diagonal 1s kind of a thing in the coefficient matrix by doing some manipulations. What are we actually allowed to do? What are the legal matrix operations? They're not difficult. They're the same as what we can do with equations, basically. We can switch any two equations. I should say we can switch any two rows. And the notation for that, for instance, I have here row 3 getting switched with row 1. Okay? That big R means row. And the little number is which row. We can, just like we can multiply both sides of any equation by a number, we can multiply any row by a number. Okay, now the notation here I have is that I'm going to replace row 1. I'm going to take row 1, multiply it by 2, and I'm going to replace that into row 1. Okay? In other words, put twice row 1 into what is row 1. Of course, if I can multiply, I can also divide. I can divide any row by a number. And what I've got here is row 3, divide it by 2, and put that, answer instead of row 3. I can add any two rows. This is saying row 3 plus row 2, put that in place of row 3. Okay? There's one limitation to doing all these things. You can do any mixture thereof at any time. But if you replace a row with anything, you must include some reference to that original row in the operation that you replaced it with. Otherwise, you've lost all the wisdom of the original row. Oh, you know, you kind of lost that equation out of your system. Okay? Like, for instance, in this case, if I'm going to replace row 3 better be in the equation that I had, and I see that it is. Okay? Get the idea? In this case, if I'm going to replace row 3 better be in the original equation. Got the idea? Row 1 better be in the original operation. Okay, whatever you get replaced. Now, the other one is a switch. That's not going to be a problem. Okay?
And now, ladies and gentlemen, let's get ready to rumble!
Let's try and solve this augmented matrix by doing a couple of those operations. Okay? Relax. I'm going to do it for you. Okay? And see if you can get the idea. Remember what my goal is. It's the diagonal ones and everything else 0. And then that's for the coefficient matrix, where the letters would be. The other numbers, the constant matrix, can be anything because they're the answers. Okay, so only kind of keep your eyes on the coefficient matrix, the left side of the line, if you would.
I want to tell you my secret now.
Okay, here's the secret. We're always going to try to do a manipulation that creates zeros. Now, ones are good. Don't get me wrong. Ones are good. But zeros are what you want to get first. Use zeros to get the ones rather than ones to get the zeros. Okay, because zeros aren't going to make a mess if you do something else to them. Anything times a 0 or you add 0 to something, it doesn't mess up some work that perhaps you had already done. Okay, it's going to stay the same. So we want to get zeros first. I'm going to start off with something you think I kind of pulled out of the air. I'm going to multiply row 1 by -2, take that result and add it to row 2, and replace row 2 with all that. Once again, I'm going to multiply row 1 by -2, and then add row 2. What's that going to do? Multiply row 1 by -2. It's going to make that 1 into a -2, and if I add it to the 2, I'm going to have a 0 on the bottom left position. That's my goal. See what happens? Okay? See if you can see what we did there. We multiplied 1 by -2 and added it to 2. We multiplied 3 by -2 and added it to -1. And then we multiplied 8 by -2 and added it to 4. And that was my answer. And I'm going to replace row 2 with that. Okay? See the advantage of that? Now I have a 0 in one of those great positions where I want a 0. I want diagonal ones, but I want everything else to be a 0. And as I said, I want you to create zeros first. Okay, now I'll start working with this one. What should we do next? I'm going to divide row 2 by -7. And I'm going to take that answer and put it instead of row 2. Why would I do that? Divide row 2 by -7. Well, that's going to make that -7 into a 1, isn't it? You love 1 in that position because you wanted diagonal ones. Of course, I'm going to get 12/7, but I can live with that. I don't care what's in the constant matrix because those are the answers. So let's replace that into row 2. And I'll get that 1 that I love. Now, who do we have to clean up at this point? I hope you appreciate. I'm going to have to turn that 3 into a 0 somehow. Well, let's see. How about if I multiply row 2 by -3? That's going to be 1 by -3, and add that to row 1. That'll kill that 3. And the nice thing is, you see, I had gotten a 0 first. If you multiply 0 by anything, you still get 0. If you add 0 to anything, it doesn't change it. It's not going to ruin that nice sweet 1 up at the top left. See why we get zeros first? So let's do this. Multiply row 2 by -3 and take the result and add it to row 1. Let's see what we get. 27ths. Of course, I get my 0 in the other position. And I'm going to replace that into row 1. And I love that because that's going to be a 0 right there.
What happened?
Well, what happened now is that you've got reduced row echelon form, and you basically have the answer. You have to recognize when you have the answer to a system. We've got diagonal 1s and all the rest 0s for the coefficient matrix. So now we can work backwards. Turn it back into an equation. The first line, the first row would be x, because there's no y. X would be 27ths, and that's the answer for x. And the second one is y is 12/7, and that's your answer.
You just won $1 million.
How cool is that? Okay? Now, you might think, well, that's a little bit harder than what I've done before, but this same method will work for 3, 4, and 5. It's going to be difficult, but 3, 4, and 5 variable systems.
You've got troubles, Mac.
How about this one? Let's begin by certainly representing this system with a matrix. Let's see.
Oh, will you help me? Can you help me?
That's a tough matrix. Okay, note your numbers. Let's take a second to digest this. The first row has a 2, a 4, a 2, and a 0 from 2x plus 4y plus 2z equals 0. The second one's not tough. It's a bunch of 1s because you have 1x, 1y, 1z, and negative 1. Third one might be a little tricky because there's a z missing. Note that we put the 0 instead of the z, but we still have the 2, the negative 1 for the minus y, and then the 0, and the minus 1. And everything stays in the same order. Okay? And remember in this case what our goal is. I really don't care what ends up in the constant matrix on the right side. It's the left side that I'm looking for diagonal 1s and all the rest 0s. Now let's look at what we have, because we may already have some good. I got a bunch of 1s in there, okay, but they're in the wrong place, kind of. Okay, and there's many ways to do this, so don't think that my way is the only way. I'm just going to give you some practice into doing some of the manipulations. I'm going to start off by flipping row 1 and row 2, because I love that 1 in the top left. And I basically, in addition to always trying to get 0s, my suggestion is to try and work your way from the top left down to the bottom right. So let me flip those and see what happens. Okay, they're flipped, and that bought me something. I still have that 1 in the top left, and I like that. Okay?
Well, ooh-la-dee-da.
Well, that's a start.
Alrighty then.
Now let's start getting 0s. And I can use the 1 and some negativity, if you would, to start killing the other numbers, if you would. Watch what I do. Let's take row 1, multiply it by negative 2, the opposite of the 2 right below it, and add it to row 2, and that's what we'll change row 2 into. You get the idea? Multiply row 1 by a negative 2, add it to row 2. Of course, at least in that first position, we'll get a 0, and we'll replace row 2 with that. And look what we get. We get a 1 times negative 2 plus 2, and that gave us the 0. We get a 1 times negative 2, and add it to 4, we get a 2. We get a 1 times negative 2, get a negative 2, and hey, we get another 0. We replace row 2 with that. That's great. That's just what we wanted. We want a 0 in that position. We kind of got a bonus 0 that time. That's sweet. We got lucky on that one. We got a bonus 0. Usually you get them one at a time. Okay, so we're working our way through here. What can we do next? Think about it. I'm going to multiply row 1, I love to use the 1s, by negative 2 and add it to row 3. Now, what's that going to take care of? That's going to take care of that bottom left 2. That's what my goal was. So I'll multiply row 1 by negative 2 and add it to row 3, and that's what I'll replace row 3 with. And it did, in fact, take care of it, as you can see. Negative 2 times 1 plus the 2 is 0. Negative 2 times 1 plus negative 1 is negative 3. Negative 2 times positive 1 plus 0 is negative 2. Okay? And I complete everything. Negative 1 times negative 2 is 3. I'm sorry, negative 1 times negative 2 is negative 2, is positive 2. Plus negative 1 is 1. Okay? So the only thing I really cleaned up is that bottom left 2, and he turned into a 0, and that's good. And I'll replace row 3 with that. Okay? And that's what I'm looking at now. I'm getting there. Need a couple more zeros. Let's divide. Now I'm going to create a 1 in this one. I'm going to take row 2 and divide it by 2. What's going to happen? It's going to change that 2 into a 1. Got to do it to the whole row, though. Okay, take all of row 2 and divide it by 2. And that's what I get. Look at it. All of row 2 and divide it by 2. And put that in instead of row 2. Note that the 0 is not going to change. 0 divided by 2 is still 0. That's why I tell you again, always start getting your zeros first. The 1s come a little bit later. Okay? I've got almost all my 1s. Probably need to do something to row 3. He's the biggest mess here. He's got things other than 1s and 0s. I'm going to multiply row 2 by the number 3. Why did I want that? Because I want to get rid of that negative 3 down at the bottom there. I'm going to multiply row 2 by 3 and add it to row 3, and that'll kill that negative 3, won't it? Okay, so once again, multiply row 2 by the number 3, add it to the actual third row, and replace the third row with that calculation. And look what I get. What do you love?
I meant to do that.
Remember, see, and the nice thing is, the zeros didn't mess anything else up, because when I multiply the 0 by 3, I still get 0, and if I add it to something, I still doesn't change it. Okay, so it doesn't mess up something you've already done. So let's replace row 3 with that calculation. And I'll have that 0. Ooh, I'm real close. Okay, now I'm going to get back on the 0 train, and I'm going to take that 1 that's in the top right position and try and turn him into a 0. Okay? Let's see. I'm going to take row 3, divide it by 2, and then add row 1, and that's what I'm going to put in for row 1. Do it again. Take row 3, divide it by 2. Of course, the zeros won't be a factor. They'll end up being 0. I'm going to take that negative 2, basically, divide it by 2, and it'll become a negative 1. Add it to row 1's positive 1, and that'll create a 0 for me. See how sweet that'll look? That's why I need a 0 in that top right, I should say top right of the coefficient matrix. And I'll replace row 1 with that. And that'll create that home run of a 0 right there. Now I'm looking good. I'm getting there. Now let's create a 1 in the bottom right. Once I have a bunch of zeros, I can start working on 1s. I'm going to divide row 3 by negative 2 and replace row 3 with that. Okay, row 3 divided by negative 2, 0 divided by negative 2, 0 divided by negative 2, negative 2 divided by negative 2 is a positive 1. And of course your 4 divided by negative 2 is negative 2. And what are we going to do? Replace row 3 with that. And look at that 1. You love that 1 in the diagonal 1's position. Okay, we have one more troublemaker. We got to get rid of that second 1 in the first row, don't we? Well, I think I'm going to have to use row 2 with that. Okay, I'm going to multiply row 2 by a -1, kind of make the opposite of it, and add it to row 1. And that'll kill it, won't it? And replace row 1 with that. Once again, multiply row 2 by -1. The zeros will just be zeros. It's that middle number I want to get. And add it to row 1, and they'll be opposites. And that's what I'll get. And our reward is that middle 0. You love that. Because if we replace row 1 with this row, you've got what we call reduced row echelon form. And basically, you're done. We have, remember what reduced row echelon form is? Diagonal 1s and the rest zeros. If we go backwards to the equations, we'll have our answers. The first row only has a 1 in the x position, so x, or 1x, is the constant 0. The second row has a 1 in the y position, so the y, in this case, equals its constant 1. And the third row has a 1 in the z position, and z will equal -2. And that's all for that one. Okay, that was a tough problem. I might not give you one quite that hard, but you get the idea of the manipulations. Note the strategy. We try to get zeros first, and then we try to get our 1s. Okay, let's try another. This one looks maybe difficult, but I think it's going to be easier because there's a lot of missing numbers, and of course those missing numbers will become zeros. Let's use an augmented matrix to do this. Okay, once again, a 3-variable equation. This is about the only way to do it. 3-variable system. I'm going to need 3 equations, and I have them. Note the first row is going to be represented by 1, 2, 1, 7, because 1x plus 2y plus 1z equals 7. The second row doesn't have an x, so I'll have to replace it with a 0. 0, x plus 1y plus 3z equals 4, so we get 0, 1, 3, 4. And the third row doesn't have anything but a -y. Known downtown as -1y, so I'm going to have 0, -1, 0, and 0 for the constant. Now remember what your dream is. It's to get this reduced row echelon form where you have diagonal 1s and the rest zeros in the coefficient part, coefficient matrix, and whatever the answers are, I'm not going to worry about them. They'll fix themselves in the constant matrix part. Okay, that last column. Let's see. We've got some good zeros going on here. Let's see if we can. They're not in the right position though. That's not good. Where can I put him that would be correct? Wouldn't he be good in row 2? Let's replace row 2 and I say replace. Let's switch row 2 and row 3. Okay, and then he'll be in a good spot. There we go. Okay, I switched them, and I've got a bunch of good zeros already. Okay, and a couple good 1s. Now let's see. I'm going to add row 2 and row 3. Look at row 2 and row 3. That's a -1 and a 1. I'm going to add them together, and I'm going to put them into, which row do you think I should put them into? Of course, they're going to become a 0. I'm going to put them in row 3. I'm not going to put them in row 2 because I want a 1 in the middle there. Put them in row 3. Okay, add row 2 and row 3, and look what I get. I'm going to put that instead of row 3. Let's do it. That'll give me that 0 which I want. There it is. I'm getting, this one's going way faster. Okay, let's see. What else do I want to get? I'm going to divide row 3 by -3. That's going to turn that 3 into a -1, and I'm going to add it to row 1, and I'm going to replace row 1 with it. And what was my goal there, do you think? I'm going to try and kill that top right 1 is my goal. Turn him into a 0. Remember, always create zeros first. So divide row 3 by -3 and add the result to row 1 and replace row 1 with that. What am I going to get? I had to do a little bit of craziness, didn't I? I had to do a little bit of craziness because I got that 17/3. Now, wait a minute. I got the 0. You having trouble with the 17/3?
I'm trying to think, but nothing happens.
Okay, let me tell you where that came from. If I divide row 3 by -3, remember 4 divided by -3 is going to be -4/3. Okay, I put the negative in the top. And if I add row 1 to that, now what is 7 as thirds? It's 21/3. And if I add those two together, 21/3 and -4/3, 21 minus 4, 17/3. That's where he came from. Okay, I didn't say this was that easy. You got to know your pre-algebra, though. Okay, and we'll replace that. We did get our 0 out of this, though, didn't we? Okay, we're getting close. We're getting close. I'm going to multiply row 2 by 2. And what's that going to do? That's going to make it the opposite of row 1 above it, isn't it? Multiply that negative. I'm not even looking at the zeros. Multiply that -1 by 2 and add it to row 1, and I'll replace it with row 1. And that'll turn that 2 into a 0, won't it? Let's do it. The other zeros aren't going to have much effect. Okay, I get 10017/3, and I love that 0. I'm going to put that right there. I'm going to put that in row 1. Okay, how close are we? Well, I think we're going to do basically a bunch of divisions here. A bunch of divisions, because we have our zeros. All we need is our 1s. So we'll divide by -1. We'll divide row 2 by -1 to create a 1 and replace it with row 2. That's good. Notice 0 divided by -1 is still 0. Replace all this into row 2, and that'll give me that 1 that I need. Let's finish this baby up. All we have left is to turn that 3 in the bottom row into a 1, and we'll have our reduced row echelon form. What are we going to do since we already have our zeros? Let's divide by 3. Okay? Divide row 3 by 3. That'll turn him into a 1. There he is. Of course, 4 divided by 3 is 4/3. This is the big leagues. Don't be crying on me. And look what we have.
How sweet it is.
Reduced row echelon form. You did it. All we got to do now is basically icing, is turn it back into an equation, which is very simple. The first row, x is going to be 17/3. The second row, y is going to be 0. And the third row, z is going to be 4/3. And there's your answer. Okay, now that's a lot of work, isn't it? And if you make one little mistake, you're going to be screwed down the way. So you probably want to take these answers and check them back into the original equations. I'm not going to take the time to do that because I think you should know how to do that. Okay? I'm just showing you the matrix operations here. Oh, homework time.